Hi everyone, today we are going to discuss a problem on recursion and backtracking. This is a success. So it says given an integer's nums of unique elements, then return all possible subsets. The solution set must not contain duplicate subsets. So it says return the solution in order. So the question is basically says you have to return all possible combinations of subsets. Just like if the subset is given is 1 2 3, then you have to return all possible subsets could be formed, just like empty subsets and only 1 only 2 and 1 2 and only 3 1 3 and 2 3 and 1 2 3. So the question is very simple. It's just like you have to return all possible combination. So we can also do this using, first of all, we start from at this element and we can say we can pick this element or not, and if pick then what, and if not pick then what conditions come. So we can check it if so we can. So if we take example, just like in our subset the number is 1341. We have to find all the possible subsets could be formed. So what we gonna do, first we are at 1, we can say we can pick one or not. If we pick one, at first the subset will empty, and when we pick one, the subsets will becomes and one, and we not pick, then subsets as it earlier is empty. Okay, so if we pick, if we now at this point, if we at this point one is comes into subset, then it's point onto 3. You can say if we pick 3, then it becomes 1 3. If we not pick, then it is as earlier only one element in the subset. So at this point in empty subset, if we pick 3, then it became 3, and if we not pick, then it's as empty as earlier. So there were only the two conditions comes. If we pick 1 3, then it's point to 4 element. If we pick 4 element, then it becomes 1 3 4. If we not pick, then it is as earlier 1 3. So if we at this point, if we pick at this point at 1 3, if we pick, it becomes 1 3. If we pick 1 3, then it becomes 1 3. If we not pick, then it's as earlier as 1. So at this time we are at 3. If we are picked, then it became 3 4, and we not pick, then it is as 3 as earlier. So it is not pick condition, and 4 is already picked. So I picked 1, so it becomes 1. It picks 1. If it not picks, then it becomes empty. So you can see this is the all the combination or form, all the possible subset combinations to be possible are here. Okay, so in this, when it captures 3, and after this capture 4, and if it not takes, then it is 3, and after this there is one element is also left. So there one again two conditions comes. If it takes 1, then it becomes 3 4 1. If it not takes, then it is as it is 3 4, and if it is at 3, when it is takes, then it becomes of this also, this becomes 3 4. If it is not tax, it is 3 as it is. And at this condition we are pointing to one empty subset, and for empty subsets we can take 3 we cannot take 3, this is empty. And after 3 there are again 2 condition, we can take 4, and if we not take 4, then it is 3 as it is, and after 3 as it is, if we take 1, then it again becomes 3 for 1, and it is again becomes 3. So this is there is all the possible subset pair were formed. So if you take example for 2 digit, then we can see what I want to say. If you take 1, there are 2 possible conditions, you can take or you not take. If you take, then the empty subsets comes one element. If you not take, then it is empty as earlier. And in 1, if you take, so it's a star pointing to 2, so if you takes 2, then it becomes 1 2. If you not takes, then it is as earlier 1. And for empty subset, if you not take, then if you take 2, then it becomes 2. If you not take, then it becomes empty. So there were 4 possible pairs is formed. What you gonna see? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So for 4 possible number of pairs, there were 16 subset pair were formed, and for 2 there were 4 total number of subset is formed. So we can say this total number of subset were formed is 2 to power n, where n is the number of size of the array. So if so first approaches, how we gonna implement this into code. So what we see it when it take, so we need to make two conditions. When it takes, then what function it calls, and when it not takes, then what the function calls. Okay, so we need to come on to our code part. So for writing your recursion code into code, first you need to define your clear requirement of your function. So in function means what is your initial state, and if you take, then what is the becomes instruction. Okay, so while writing your recursion into code, you must define your uh, recursion function first. So this is our recursion function name is generate, in which first thing we have to write is in what data structure you are working on. So we can see we can see so at this point, first you need to define in which data structure you are working on. We are saying we are working on vector of array. So we need to define our vector of array. So we can say we are on working on vector of array. So you can say this vector of array names anything, like I say this subset. So on each, so when you check what type of elements you take on each step. So I says I take height element on each step. So we pass int I, we can pass anything. So after int I, we need to pass instances of vector where subsets hold. Like I'm gonna tell you, first need to pass by reference, because we do not want to create their copies. Okay, this is the section. At this point, okay, you wanna see when the subset is formed, they are present in the instances which is created by your nums. So when we forming subsets, their values are come into an instances, so which is represented by nums. So at this point, where we are, okay, we are at, let us see, we are at instances now. what we need to do is we need to define when we not take, then what happens, and when we take, then what happens. Okay, so if we not take, when we not take, so then what happens, then our function calls itself. First we define when we not take. So what is this? It is just message all the functions. Okay, no instances for that function. You not define well. Okay, so we need to have a define. So first thing we says when we not take, then what happens? When we not take, then we search for our next value. We just put their values as it is. So I says subset will as it is, and I start searching for the next element, and none instances is also as it is. So after writing will not text, then we need to define when text, then what happens. So when text for this function, then what I say is when we take the element, you can see this here. When we take the element, then what happens? When we take the element, we push back into our array subset. Okay, it is an subset array. The instances is nums, but we are at subset array. So in subset array, no, this is a nums array. Okay, so at nums array, what we say is we just push back that element. Okay, when we are at this instance, we just push back the current element. We just push back the current element, just like I is pointing at 3. We just push back the current element into the array, and after currently push back element, we need to pop it back out again. Why pop it back? Because we do not want to send their data onto our next call. So we need to also pop back data. Okay, so we can say, so we are at this step. I can say when take, then push back into subset array, push back our nums of I. Okay, when I can say push back the current element into subset and call the function again. Why we call? Let's see why we call the function again. We can see here when we call the function, then it again goes on to occur. When if we not call, then it does not calling again. So for when it calls again, then it comes here for check when we not to pick. So we need to call it again. So at this point we can say we call it for subset check for I plus 1 element. Okay, at this point we are check for when we call, then we are check for I plus 1 elements. Okay, just like when we call 1 3, then it comes here to call check for 1 3 4. First it checks, then it again calls again. So you not to confuse that it moves only one direction, but it goes on to the depth of the tree, then it again come back. So never confuse on them. Okay, so we can say generate subset I plus 1, and consistency is also there. So after consistent, we need to push back because we do not want to copy their data for our next call. So we can say that in subset dot pop back our last instances. So after last instances pop back, we need to define our base condition. What will be the base condition? When all the elements were when we search for all the elements, there were no elements were left. So when our vectors, when our iterator points to the last element, or we can say the vector points to the size of the element, then then return, then simply push back all the subset into vector, because we want vector of vectors, because we want all subset of vectors in one vector. So we simply says for our base condition, if nums dot size size equal to, if I equal to nums dot size equal to nums dot size, then I equal to nums dot size, and in subset we need to create a new vector array. For subsets we can say that I'm gonna create a new array, new vector of vectors in which all subsets were present. Okay, so I'm going to create a vector of array, and you can say this in subsets into same column. You can say in subsets push back current element, which is in pushback pushback all the in subset pushback all the subset which you found, and after subset then return our result. You can see this, and the code is over, the code is done. So let's check this code is passed on to VS Code or not. This code is run onto on Leetcode or not. So defining this question, we consult on Leetcode. So we pass our generate vector and this file subset in dynams. In subset vector 182, we need to pass our function which is generate, and generate what we pass subset subset at this point. Let's check it runs or not. This is subset different conversion subsets. Okay, so we need to change our function name. The subsets could not be same, so we can make it as subsets. We can say this as sub. Okay, we can call it as sub, and we can choose sub here. We can pass our subset. Okay, at this point, so the subsets became the same name. We can change it to divider. We can make it subset function. Okay, we have subset function. We need to change it this subsets, and we can see then we can make it as sub a subset now we can do that. We can also change it, and we can say that our initial value is 0. So we are at the starting at 0th index, so our initial value is 0, and our array is sub. We need to also make this subset to pass a subset. After this we need to return it. This is return So we want vector of vector array, so we can say return subset. Okay, vector of all subset array. Let's see if it will runs or not. It will be solved because we are already seeing. What is the problem? The subset. He said equal to non-static equivalent must call. Okay, why do you not call that subset? That subset. That's fine. Let's see if it will run or not. So this is what we're talking about. Okay, so here details now why it just says so so we are pushbacking into sub, which is an error. We need to push back into vector first. So at this time we can say okay subset. Let's see if it runs or not. It says commas or there. So total to the power n plus perform. We need to pause and subset. So as this is here, I will declare a subset because it will be a subset here. Total to the power depth of trees in for n versus you can consider in the for construction of the tree. Okay, so we just change the mean, so it does not mismatch. So now we will need to run it. So it gives wrong answer. Let's see. Okay, our output is empty vector because it not run for all this time. Okay, it only runs for empty vector, and we need to find out. So at this time our code will run. So we need to test all, submit it and check it will pass all the test cases or not. So you can see it passes all the test cases. So if we talk about their time complexity, so if we talk about time complexity and space complexity, so we are making a code for using backtracking and recursion, uh, where there were two choices, include it or in, include it or not include it. So on each cause there were to the power n subsets performed. So each cause is, so the total time complexity will become b of n into to the power n. And if we talk about the time complexity, so the subset vector in the subset vector for all to the power n subsets, there were subsets were in sub the subsets were integers for to the power n calls. So the time complexity for each call is b of n. So the total space complexity is becomes also b of n into b of 2n, b of n into to the 2 to power n. So this is for today. Welcome to our next video. We are coming back on our next video. Thank you.